morning, students. Today, in the mechanism of machines continuation, we are going to see the balancing of the rotating masses. So, the balancing, all the revolving object and also the static object, it should be perfectly balanced. If it is not perfectly balanced, or the object which is not balanced, it is not in the stable condition. It may fall anytime. So, the balancing is required for all rotating object as well as for the static object also. So the balancing of the masses, here I am taking it is a rotating masses. So the balancing of rotating masses that can be classified into static balancing and a dynamic balancing. So the static balancing, the balancing of single rotating mass by balancing mass in simple plane and different planes. So the static balancing means the object is in the stationary condition. For example, if you are taking the rotor, so the rotor will be having so many blades. That blades are assembled on the rotor. That rotor is revolving on the turbine, steam turbine. So the steam turbine rotor, it will be very lengthy. It will be maybe 2 meter or 3 meter. In that, there may be a series of blades which are assembled, maybe 10 lines or maybe 12 lines. So each and every blades assembled on the rotor, it should be balanced. Then only the load acting on the bearing will be supported equally. So there no wear and tear happen in the static condition also. Suppose the rotor which are unbalanced, so the force acting on the bearing, that means the dynamic load, will be enormous. So it may create so many vibration. So frequently the bearing support having a failure. So it may damage the system. So each and every time, so frequently you have to replace the bearing assembly. So in order to avoid that, you have to ensure the rotor assemble, which is assembled for running on the turbine, it is balanced or not. So that balancing, when it is not rotating, that is what you call it as a static balancing. So that static balancing will be on the simple plane, only one plane, and also only one mass. So how that can be balanced? So place the balancing mass on the opposite to the direction of the unbalanced mass location. That is a simple method. Example for a weighing machine. So if you are putting a 500 kg, 500 grams, opposite to the direction, place 500 grams. Then the pointer will show in the equilibrium condition. Same thing. Now, balancing of several masses by balancing mass in the same plane. That means if there is more than 2 number of unbalanced force on a single rotor, there is a more than 2 unbalancing mass which is on the same rotor, how that can be balanced. So same thing, how the system will be acting by several number of forces. That means more than 2 forces acting on the system. Similarly, you have to go by the Polygon law of forces, or you have to go by analytical method. So what you do is, locate the unbalanced mass on the rotor. Mark that one is M1. And then keep the reference with the horizontal. Make that one is a theta 1. So M1, theta 1. Similarly, go for M2. M2 is the another location of the unbalanced mass on the same rotor. Mark that is M2 and then locate the angle is theta 2. Similarly, locate the unbalanced mass on the rotor with the M3 and then mark that angle is theta 3. Similarly, you can go how many number of unbalanced mass which are present on the single rotor. So how that can be balanced? So this system, how that can be balanced is nothing but the centrifugal force. So you know the centrifugal force because it is the rotor starts rotating. Once it is start rotating, it is having the effect of centrifugal force. So that centrifugal force, if it is balanced one, no problem. So the rotor will be running very smoothly. If it is unbalanced mass is present on the rotor, it may create the wobbling or it may create vibration. So continuous vibration creates dynamic force on the bearing. That dynamic force will be taken up by the bearing. That leads to reducing the life of the bearing. So replacing the bearing, and then the life of the bearing is also going. So there is a frequent failure of the turbine on the steam generator. So that can be avoided. So what you have to do is you have to make a unbalanced mass. So what you do is attach the single mass replaced by that all unbalanced masses. How that can be calculated? By using the analytical method, then graphical method. Centrifugal force, m omega square r. So here that omega is constant. Take the effect of m1 r1 plus m2 r2 m3 r3. Make that one is horizontal component, vertical component. So resultant is equal to sum of all vertical component square plus all horizontal component square. So find out the resultant mass. And then the magnitude, direction is tan theta is equal to sum of all vertical forces divided by sum of all horizontal forces. So find out the angle. Now locate the unbalanced mass. That means all that unbalanced mass can be replaced by a single mass. That single mass is added to the system or it can be removed. So there is a two way of balancing of mass. One is adding the mass, another one is subtracting the mass. So here you can add the mass to balance the unbalanced mass on the rotor. So up to this I am stopping. You will continue in the next class. Thank you.